Good morning, good afternoon, or good evening, depending upon where you live around the world. Yes, indeed, I am back, and I have sort of stepped ahead a little bit to no real end conclusion other than it might work. It might be a good idea. And what am I talking about? Of course, it's the hub and strut connections and the interface that will come from that, should I go ahead with this, that is able to be built within a common workshop that you would be able to go out to and grab the existing tools and have at it and create this sort of hub structure. I have now shown, running through my mind, the idea that perhaps a split ring, so two-part hub, could be an option. I don't know, thinking about it, whether it will be much of an option or much benefit, because the idea being that the split ring would permit me to have two distinctly different fixing methods, and any limitations of the depth would be eliminated. But then I was thinking about it, and I thought, well, really? What advantage, actually I'll just unhide some stuff, what advantage does a split ring setup have over a solid ring? And I can't come up with a reason as yet. Now, there is, if I hide that, if I were to have a slot in this direction instead of just a hole, well, that would first of all weaken the steel hub somewhat. It's a fairly heavy walled pipe, so that would not necessarily be an advantage, but it would mean that I could insert the ring from underneath over the fixings that are in the timber, the bolts. And ditto, if I had a slot down this way, I could then slot the ring, the top ring, over top of the already inserted but yet to be fully engaged screws. Now, there's a little bit of a real world problem with that. Sometimes when you insert a screw, you really want to insert it once. These are fairly heavy screws, so there may or may not be an issue with it, but they are fairly long and therefore quite a bit of friction. I would not want to insert a heavy screw and it be left for, like a few hours or a few days, and then go to re-tighten it and it snap, because the screws can actually bind in timber at times and cause issues. Hopefully that wasn't the case. It may be that a little bit of lubricant, which is a rather strange thing to have on the screws, could break that bonding or binding nature of some screws. I've got no idea how to quantify that. Would it be that much of an issue? Don't know, but I have snapped screws in the past, and some choice words were used. But this idea of being able to slot over the rings means that any assembly issues, when you're triangulating something, the more struts or ready assembled triangles that you would have could become a wee bit of an issue, and this would certainly get over it. So, but I tell you what, while we're talking about it, I will draw in a photo, so I'll pause it and I'll be back momentarily. And we're back again. This was the hub system that I was talking about. A little bit hard to see even when I zoom in, but this design has a two-piece hub design. You can probably see it down in this corner here. So that's the upper part and that's the lower part. they can be slipped over already inserted bolt heads, and then with the plate top and bottom they can be clamped together. So that was sort of what I was contemplating, a slight variation on the theme. It's not a particularly heavy steel, so that's a big plus for cost and working on it in the workshop. And it's not actually all that big. I would estimate that it would be 75, maybe 100 millimeters in diameter for the hub. And you can see this one here, they've yet to slot on the lower ring. So that's got a lot going for it. You can see in some of the ones that they've yet to install, just see that they're hard to see, but there are 2 bolts inserted into the hub. Not very far apart, so I don't consider that very strong. However, strong enough for a dome of this size, which is quite a good size. And this is a full circular type dome, the hexagon and pentagon type scenario, and it probably is a 3V, possibly a 3V dome. So maybe a 4V, I'm not too certain. But that was the idea for the situation we've got here. I didn't want to clamp it together this way. I don't see that as all that necessary. However, one of the benefits of having a single hub means that there can't be any twisting action between the 2 hubs, the 2 parts of the hub, because it could well be under load that the pressures on these 2 fixing methods could skew the alignment. Would that be a problem? I doubt it. If there's a rigid cladding on it, that would stabilize this timber, the strut, but just a thought. I'll just pause again and bring in another photo just to clarify what I'm thinking, so just wait there. Yes, and we're back again, and this was the idea here. It's odd, I'm not too certain why they've got these plates on top and bottom in the bolt. It's just kind of telling me that there's a bit missing. This may be one drawing that was or wasn't used, and it was just maybe a section of it. Not too certain what they're showing in this case, but again, same thing. And to be fair, in the installations of the much preferred system that I really do like, the Altbar produced type of dome, they too, with their big solid manufactured hubs, have a similar sort of slotting in capability for their strut to land in initially, at least. And this is, just having it here, you can see that they have got the nice big solid manufactured hub. They can insert in effectively a key way the head of the bolt, and as they slip down, it physically and positively locates the head in the slot, and of course it slots down onto this one as well. So that's a really nice way of assembly for individual struts, like the big domes that we see that this particular company has. So it is a viable option. Nice heavy steel and no deflection of the head. The beauty of this is really lovely sort of engineering. Not something I want to do, but they've got the capability of doing it. But everything's flat. Even though the ends of the strut are angled correctly, or they may be square and these are angled rather, the bolt heads are flush on the surface, so not a circle sort of issue that I've got. But this, the more I look at that particular company, they do a fantastic design and build type of dome, so well done to them. But I'm a lowly builder, non-engineer, and I want to do this in my workshop, which is a carpentry workshop, and I think I'm capable of this, maybe less so on those nice big welded up and angled to a very specific shape and size hubs. So single ring or a double ring? Not certain. The other issue that a single hub has, another good issue, is that any chance of splitting the timber is eliminated, whereas this introduces that possibility. I don't think it would ever be an issue at all. I'm just being overly cautious for no real good reason, but I think I'll leave it there. I'm probably being a bit paranoid for no good reason. I'd toss this one onto the back burner, thinking that if in the process of making a model or a small dome I find this to be advantageous, I'll try it. If it proves to be a pain in the bum, it'll be thrown out, and it was at no real cost to the dome or the procedure. So I think that is enough for that just now. The next one will be looking at the wisdom, or not, of using an angled batten on top of the strut with the dihedral angles cut into that batten, so that should you want to land, say, plywood on the struts, you have got the angles already cut into them, rather than having to do it to the heavier timbers. You've got a batten that much easier to handle and make in the workshop, and it has the advantage that if we want to be geometrically accurate, not all struts relative to each other are at the same level. They are only at the same level when you take the center line point that angles up to the geometric line at the hub. I'll show that in the next video, but that's true. Is it sufficiently, are they at a sufficiently dissimilar level that it would cause problems? Probably not. But if we address it now and we need to include it, we have at least thought about it and mitigated the issues that might, again, bite us in the bum, should that be an issue. I can't see it with the materials I'm anticipating using, which will have some sort of flex. I doubt that. Not certain whether I'd ever use glass in this scenario. The cost, though, it would have to be laminated glass or safety glass, preferably laminated, but again that becomes a cost reality. However, putting polycarbonate in is also a cost. So my idea is to use an agricultural polythene type, polyethylene sort of tape membrane, which again it wouldn't matter at all what the differences between the struts are, which we're only talking maybe 5 to 10 millimeters at the most. So I'm introducing a problem that may not necessarily exist in reality. Okay, with that I will bid you goodbye, and I'll see you in the next one. Radio. See you later.